this anterior wave. Now we want to look at septation of the heart. Please, if you haven't watched my previous video on the development of the heart, go and watch it so that you can understand what we want to look at here. In my previous video, I've talked about how the heart tube develops. I've talked about the structures of the heart tube. I've talked about cardiac looping, where we determine the shape of the heart. Now we want to look at the septation of the heart. You know, when I talk about cardiac looping, I said we already have the primitive atrium, which is the right and left atrium in their original position, and also the ventricle, the bulbous cordis, which will give rise to our right ventricle, and the primitive ventricle, which will give rise to our left ventricle. We are formed there during cardiac looping. Now, in each chambers of the heart, we want to form septation, a septa between the right AV canal and the left AV canal. After that, we are also going to form septation between the two upper chambers, which is the right and left atrium, and the two lower chambers, which is the right and left ventricle. Now let's dive into it. Now, if you don't forget, this is the structure of the heart tube. Yeah, so this is the heart tube. We have here to be the what? Bulbous cordis, the primitive ventricle, the primitive atrium, the sinus venosus, and the arm of the sinus venosus. So this is my what? Truncus arteriosus. This is my what? Bulbous cordis, primitive ventricle, primitive atrium, and the sinus venosus. Then here we have the right arm and the left arm. I've explained this structure of the heart tube in details. Now, during cardiac looping, this is the shape of the heart. When this heart tube undergoes changes, bending action, then this is how it looks like. Here we have the primitive atrium here, the right atrium and the left atrium. And here we have the bulbous cordis that is going to give rise to our what? Right ventricle, and primitive ventricle, which will give rise to our left ventricle. Now, in the septation of the heart, like I said, we want to look at the septa formed between the right AV canal and the left AV canal. And we also want to look at the septa formed between the atrium and the ventricles. Now, let's go into it. Now, let's take a transverse section of this part here, which is the atrium and ventricle. Let's take a transverse section, a cross-sectional view. Now, it's going to be like this. So this place here is the primitive atrium, while here is the what? Primitive ventricle. Now, we want to form septa between the atrium and the ventricle. That's what we want to look at first. Do you get to know? There are some kind of cells, we call them neural crest cells. They are ectomesenchymal cells. They migrate to different regions of the human body to give rise to structures. Now, the cells come here. Do you get? We call it what? Neural crest cells. Now, when these neural crest cells enter into this space, into this tube structure formed by the atrium and the ventricle, they begin to form an outgrowth at the atrium and ventricle. Yes, this outgrowth formed by the entry of the neural crest cell into the atrium and ventricle. That is what we call what? Endocardial cushion. Endocardial cushion. So the outgrowth formed by the neural crest cell when they enter the atrium and ventricle is what we call what? Endocardial cushion. Then do you know what happens next? The endocardial cushion begin to approach one another. Do you get? And they close up. Now it is not like this. We have like this. The endocardial cushion have closed up. This is our what? Primitive atrium, and this is our primitive ventricle. So when the endocardial cushion close up, it gives rise to what? It gives rise to what we call septum intermedium. Yes, septum what? Intermedium. That tells you that the septum intermedium separates the right AV canal away from the what? Left AV canal. Do you get what I'm saying now? So the septum intermedium formed by the endocardial cushion, do you get? Separate the atrium away from the ventricle. It separates the right AV canal away from the what? Left AV canal. Now you are going to evidently understand this when we undergo a coronal section of this heart tube. Do you get? Of this heart. Now let's undergo a coronal section. Do you get? So let's undergo a coronal section of this. Then it will be like this. Yeah, so this is a coronal section of this. Now this is our right atrium, this is our left atrium, this is my bulbous cordis. You know, the bulbous cordis later become the right ventricle. So let's use here as the right ventricle, and yet let's use here as the left ventricle. Now we already have the formation of septum intermedium. Do you get what I'm saying? We already have formation of septum intermedium. So this is our septum intermedium. Yes, these are what? Septum intermedium. So the septum intermedium is separating the right AV canal away from the left AV canal. That's what I want you to know. So you can see with the aid of this section, cross-sectional view. Now, what makes up the septum intermedium? Endocardial cushion. So coming off from the septum intermedium is also an outgrowth. Do you get? The outgrowth like this? It comes off from the septum intermedium. Do you get? This outgrowth that come off from the septum intermedium at the right side is what we call the tricuspid valve. Do you know what tricuspid valve does? The tricuspid valve separates the right atrium away from the right ventricle. So the valve that separates the right atrium from the right ventricle is what? Tricuspid valve. Do you get? They are made up of 3 cusps of valve. Now, the endocardial cushion formed here that come off from the septum intermedium is what we call what? What do we call it? Bicuspid valve. We call it what? Bicuspid valve. Bicuspid what? Valve, also known as the what? Mitral valve. Mitral valve. So the mitral valve separates the left atrium away from the left ventricle, while the tricuspid valve separates the right atrium from the right ventricle. Where are these valves formed? They are formed from what? Endocardial cushion that make up the septum intermedium. Now we have formed septation or partitioning between the AV, right AV and the left AV. Now what do you want to look like? What do you want to look at? We want to look at the septation formed between the 2 atrium and the 2 ventricle. Now let's get into it. Now let's start with the septation of the atrium. Is that you call it septation or you call it partition? Do you get what I'm saying? It is still the same. So at first, during the septation of the atrium, a ridge of tissue, a crescent-shaped ridge of tissue grows from the roof of the atrium. Now look at this tissue. The tissue comes like this. So this is the tissue here. So this crescent shape of tissue that grows from the roof of the atrium is what we call the what? Septum primum. Septum what? Primum. Do you get? It's a crescent shape of tissue that goes from the roof of the atrium at the middle part of the atrium. But guess what? The septum primum did not close up with the septum intermedium. There is still a space left here. That tells that there is a space between the septum primum and the septum intermedium. So this space left is what we call what? Ostium primum. We call it what? Ostium primum. You know, it's just like every word, but it's very simple. You know, septum primum, primary septum. Ostium primum, primary what? Space. Ostium, space. So the space found between the septum primum and the septum intermedium is what we call what? Ostium primum. Now, do you now know what happens during subsequent development? The septum primum goes down and meets up with the septum intermedium. This, are you guys following me? Before, there was a space between the septum primum and the septum intermedium. This is the space. And what is the name of the space? Ostium primum. But later on, this septum primum will go down to meet up with the septum intermedium. Now, when it goes down, what happens to the osteum primum? The osteum primum becomes obliterated. Now, let's look at this. You understand it here. Now we have like this. Yeah, so we have this as our what? Septum intermedium. We have this as our what? Mitral valve. We have this as our what? Tricuspid valve. Then we have here to be the what? Yes, I'm coming. Draw this very well. So going off from the atrium is our what? Septum primum. Do you get it? Now the space is what we call the what? Ostium primum. So when the septum primum match with the septum intermedium, now let's say it has matched. Yes. So let's say it has matched. So when it match with the what? Septum intermedium, what happens? The space here, which is called ostium primum, has become obliterated. The space disappears. Why? Because the septum primum has fused with the septum intermedium. So the space won't be there anymore. So when the ostium primum is obliterated, you know what happens next? Cell death begins to appear at the cranial part of this septum primum. Cell death, that's what we call what? Apoptosis. So when the cell death appear at the cranial part of the septum primum, guess what it forms? It also forms a space. This space what we call what? Ostium secundum. Ostium what? Secundum. Ostium secundum. Yes, that's the name of the next space formed at the cranial part of the what? Septum primum. So this is the ostium secundum. Then later on, another tissue, you know, don't forget, these are what? Right atrium, left atrium. Right ventricle, left ventricle. Now, lateral to this septum primum, another shape of tissue goes down. We call it a sickle cell shaped tissue. Do you get it? It's like a sickle shape. So when the tissue goes down, let me use this. The tissue goes down to close up the what? Ostium secundum. This tissue is what we call the what? Septum secundum. You got the septum what? Secundum. You know, this thing is very simple to get. You know, at first we have the what? Septum primum that goes down. But it leaves a space. What is the name of the space? Ostium primum. I want to see whether you understand this thing. Now, when the septum primum goes down, it closes up this space. The ostium primum. Can you see? Which has been closed up. Then after the ostium primum becomes closed up, apoptosis occurs and a space is left here, which we call what? Ostium secundum. Then lateral to the ostium secundum, another sickle-shaped tissue goes down, which we call the what? Septum secundum. Now the septum secundum forms a pretty space. Look at the space here. So the space formed between this septum secundum and this one here, which is the septum primum. So this space here formed is what we call the what? Foramen ovale. We call it what? Foramen ovale. Yeah, foramen ovale. That is the name of the space formed between the septum secundum and the septum primum. Do you get the space formed between the lower ridge of the septum secundum and the upper ridge of the septum primum? That's the name of the foramen ovale. You know, the foramen ovale is responsible for the bypassing of blood. You know, the foramen ovale allows blood to bypass the lungs. Do you get what I'm saying now? So any blood that enters into the right atrium, they pass through the foramen ovale and enters into the what? Left atrium, and the blood will be able to enter into the what? Right ventricle, which you are going to understand later on when I explain fetal and neonatal circulation. So you need to know that when the blood passes into the right atrium, they pass through the what? Foramen ovale and enter into the what? Left atrium. You are going to understand this in fetal and neonatal circulation. Yeah. Now, you know, at birth, do you understand what I'm saying? You know, all this occur before birth. So at birth, what happened? The first cry of the baby, what happens is that this, what is it called? The septum primum will match with the what? Septum secundum. You know, the first cry of the baby causes intake of air. There's rapid intake of air. So when those air oxygenate the blood, what happens? There will be filled up of blood in the left atrium, which will match this septum primum with the what? Septum secundum, to form what we call the what? Fossa ovalis. That is how this what? Septum is formed, which you are going to understand later on. So later on at birth, this foramen ovale will obliterate by margin of the septum primum and the septum secundum to form the what? Fossa ovalis. To form the what? Fossa ovalis. You know, the margin. Do you know what I'm saying now? And this is the fossa ovalis, a fibrotic tissue at birth. Now we want to look at development of this septation between the lower chambers of the heart, which is the right ventricle and the left ventricle. Now at the ventricle, what happens is that, you know, if you don't forget, these valves, which is the what? Tricuspid valve and bicuspid valve, they are connected to the muscles of the ventricle. What are the muscles of the ventricle? Papillary muscles. So there's something that is connecting the papillary muscles, there's something that is connecting the valve to the papillary muscles of the ventricle. What do we call it? We call it chordae tendineae. Do you get it now? We call it what? Chordae tendineae. Yes, this is the word called chordae tendineae. So this chordae tendineae is a fibrotic tissue. Do you get what I'm saying? That connects the valves to the papillary muscles of the ventricle. You get? The chordae tendineae holds the valve in place and ensure unidirectional movement of blood flow, so that when the blood flows from atrium into the ventricle, the blood will not be able to flow back. That's the essence of the chordae tendineae, connecting the valves to the papillary muscles of the ventricles. So in the septation of the ventricle, what happens is that around the apex of the heart, a tissue goes up. The tissue goes up. This tissue that goes up is what we call the what? Muscular portion of interventricular septum, IV septum, interventricular septum. Then later on, another tissue goes down from the septum intermediate to close up with the muscular portion. Then this is the tissue here that goes down. This tissue that goes down is what we call the what? Membranous portion of the what? IV septum. So the ventricles of the heart, we have formed septation between it by the what? Membranous portion, by the membranous portion and the muscular portion. So the membranous portion and the muscular portion come together to form the what? Interventricular septum. So that is all about septation of the heart. Now, the last thing I want to give you here is the, congenital anomaly associated with the septation of the heart. There's something we call tetralogy of Fallot. Yeah. Tetralogy of Fallot. The tetralogy of Fallot is a congenital heart defect. Do you get? There are 4 congenital heart defects that occur when the heart is developing. That is what we call the tetralogy of Fallot. And you see this tetralogy of Fallot, they causes what we call cyanotic disease. Do you get? When there is hypoxemia, do you get? Whereby there is low level of oxygen in the blood. What happens when there is low level of oxygen in the blood? And those low level of oxygen, which is poorly oxygenated blood, they begin to move to other parts of the body. You can have a bluey skin, and that's what we call cyanosis. So what are the tetralogy of Fallot? Number 1 is what we call pulmonary valve stenosis. That is the first one. Then number 2 is the what? Overriding aorta. That is second one. Number 3 is the ventricular septal defect. Ventricular septal defect. And the last tetralogy of Fallot is what? Right ventricular hypertrophy. Now let's take it one by one. The pulmonary valve stenosis, you get, when we say pulmonary valve stenosis, is a condition whereby the pulmonary valve becomes narrowed. It becomes stenosed. It is the pulmonary valve that connects the blood present in the what? Right ventricle into the lungs. Do you get? That is what we call pulmonary cellular valve. Do you get? So any blood that wants to enter the lungs, they pass from the right ventricle passes into the what? Pulmonary valve and then into the pulmonary trunk before it reaches the lung. So when this pulmonary valve becomes tenuous, that tells you that poorly oxygenated blood will not enter the lungs. And you know, if blood is not oxygenated, then and those poorly oxygenated blood goes to other part of the body, it can cause cyanotic disorder, whereby the skin will appear to be bluish in color. So that is about pulmonary valve stenosis. Then the second one is overriding aorta. Normally, the aorta should collect blood from the what? Left portion of the heart, which is the left ventricle. But now the aorta is located in the wrong position. The aorta is now collecting blood from the right ventricle, which is poorly oxygenated blood. And when the aorta collects the blood from the right ventricle, it's transporting it to other part of the body, which can also cause cyanotic disorder. That's what we call overriding aorta. Then the third one is ventricular septal defect. That's what we call hole in the ventricles. Do you get? When there's hole in this interventricular septum, when there's hole here, then what happens? There will be mixture of poorly oxygenated blood with oxygenated blood. You know, the right ventricle contain poorly oxygenated blood, while here contain oxygenated blood. So when there's hole in the ventricle, there will be mixture of blood here. Do you get? The poorly oxygenated blood will mix with the oxygenated blood, which can also call what? Cyanosis. Then the last one is right ventricular hypertrophy. This is a condition whereby there is increase in muscle mass of the right ventricle as a result of what? Pressure overload. Do you get? The right ventricle increase in muscle mass. They become thickened because they have undergo extra work. Do you get what I'm saying now? That thing can cause strain within the heart muscles. Do you understand what I'm saying? That's what we call right ventricular hypertrophy. So all these congenital heart defects can cause cyanosis, whereby there will be decreased level of oxygen in the blood, which we call hypoxemia. And as a result of that, your skin appears to become bluish in color. So that's what we call cyanosis. Now we are done with the septation of the heart, where we form septa to the atrium, to the ventricle, and also to the right and left AV canal. Please, that is all about that. Now don't forget that at the end of this video, there's always a practice question that can enhance your understanding on what septation of the heart is all about. Please don't forget to like and subscribe.